Okay, here we are on a video about pulleys. I didn't give you pictures of these first ones because you don't really need the pictures. I just want to kind of go over a couple of ideas. Pulleys are a pulley here with a rope that goes over it. You're mostly familiar with these already. And we have two kind of pulleys. We have a fixed pulley where this one is attached to the ceiling, for instance, here, and this pulley here doesn't move. Our other option would be something where there's a rope here that goes up, maybe to a motor or something, and this pulley actually moves up and down as this rope gets tightened. And that's called a movable pulley. Very unique name, I know. So here's the deal with the pulleys. They're the easiest ones to find the IMA of because the IMA is just the number of ropes that are not going in the same direction as the load. So here, my load on this one, my load is pulling down this way. So when I count my ropes, here's one rope, and here would be a second rope. But this rope is pulling in the same direction as my load. So since it's pulling in the same direction as my load, I don't count this one, so this one has an IMA of 1. Here's my load. It's going down. This one is 1. And this one, my final one, is going up, so I count this one, giving this one an IMA of 2. Basically, you count all of them except the very last effort one, and you don't count the effort one if it's going in the same direction as your load. So let me show you a little bit more challenging picture. Here's an example. We have a motorcycle, so maybe this is something in someone's garage or in a mechanic shop where we need to lift this load. And we have 4 pulleys here, but remember to get the IMA, we're going to count the number of strands. So I'm going to start here at the middle where it starts. This is 1, follow it around, here's 2, follow it around, here's 3, follow it around, here's 4, and here would be 5. But let's look. The load is going down, so do I count this last one where the effort is? No, the effort would be going the same as the load, so I don't count this one. That would mean the IMA for this one equals 4. That's all you need to do. The other thing to be aware of is if you're counting if you calculate the IMA, you use IMA equals AMA, right? You do all these calculations like we've been doing before, and I happen to get the AMA when I do FR over FE, and I get some answer like 3.4, let's say 3.9, that's what I get. What's the IMA? How many strands do I need? Well, I always round this up. If I get an AMA of 3.9, I would round it up to I'd need 4 strands. What if I get an AMA of, say, 3.2? I still have to round it up. Basically, 3 strands would not be enough in this case. 3 would not quite be enough, so I'd have to round it up to 4. So when you find the AMA and you're trying to find the number of strands, you just round up every time. Okay, so let's do a couple of examples real quick. And you have these to put in your notebook. Here's our first one. Normie Neutron attempts to lift a 50-kilogram mass. So remember, the first thing I'm going to do is start labeling. It's drawn for me already, but I'm going to label it. So this mass, this is my load. So this is my FR, and it's 50 kilograms. As shown on here, what is the mechanical advantage of this pulley system? Well, how do I find that? The IMA equal the number of strands. So let's see what we got here. Here's 1, 2. Now when he's pulling down on this, is this one counting? Well, it's not going to count because it's the same direction as this. So our IMA is 2. So what's the minimum force needed to lift the mass? Write your formula. AMA equals FR over FE, just like we've had on the rest of them. FR is 50. I don't know FE, but I do know the AMA is 2. Cross multiply, do your work here. So we find that Fe equals 50 kilograms divided by 2. Use your calculator if you have to. Hopefully you don't have to. And we get 25 kilograms. That's how much effort he's going to need to pull to lift this load. Then it says if he pulls the rope 3.46 feet. So this is my DE. He's going to pull that much rope. How high will it lift? Well, if you think about when this rope pulls, it's going to pull this up half the distance because half of it's on this side and half of it's on that side. We're still using our formula. So IMA equals DE over DR, just like we've had every time. I know the IMA is 2. His distance that he's pulling the rope out is 3.46. And I don't know how high this is going to raise. I'm looking for this distance here, how high it'll raise. Again, use your cross multiply. DR will equal 3.64 meters divided by 2. Let me grab my calculator and do it really quick. 3.64 by 2. And I get 1.82 meters that it's going to move up. So the bonus is I don't have to pull as hard, but I have to pull out twice as much rope as I get lift. Okay, now let's do our other example. Here's our pulley. What is the IMA of the pulley system? How do we find it? Count them up. So here I'm going to point out this is my load going down, and here's my effort going right here. So let's start counting. I always like to start at the middle. So here's the middle. 1, 2, 3, 4, 5. This would be 6, but do I count the 6? This effort's going the same direction as the load, so I don't count that. So IMA equals 5. If you want to lift the resistance 2 feet, so I want this to go up 2 feet, that's going to be DR. How much rope would I have to pull out? So it's asking me what is my DE. So that's IMA equals DE over DR. Write your formula out. I've done all my labeling over here. Write your formula out. IMA I know is 5. DE, I'm looking for that. DR, it said it wanted me to have 2 foot. Cross multiply, we find that we would need to pull 10 foot of rope out to get this part to go up 2 foot. Now if this resistance down here weighs 600 pounds, maybe it's that motorcycle from earlier, how much effort is it going to require me to use over here? So that's AMA. FR over FE. Write your formula out every time. Plug in your information. I know AMA is the same as IMA is 5. FR, that's right here, 600 pounds. How much effort am I going to need? Cross multiply. FE equals 600 pounds divided by 5. Plug in your calculator. And the answer is you only need to lift 120 pounds. Or, if it's not you, you might have a motor over here that could lift 120 pounds. Okay, that's it for pulleys.